Have you ever imagined what it would be like to stand at the very center of nature's most ferocious fury? To witness firsthand the raw power of a storm so immense that it defies all comprehension? Today, I invite you on an unprecedented journey into the heart of Hurricane Milton, the perfect storm that not only challenged everything we thought we knew about weather, but also altered the course of our understanding of the natural world forever. Stay with me, because what you're about to discover will leave you utterly astounded. Our story begins in the tranquil waters of the mid-Atlantic, where a seemingly innocuous cluster of thunderstorms was forming. Meteorologists observed this disturbance, but gave it little attention. After all, tropical waves like this one are common and often dissipate without incident. But within just a few short hours, this particular system began to exhibit unusual behavior. By the end of the first day, satellite images revealed that the storm was rapidly organizing. What was once a scattered collection of storms had coalesced into a well-defined cyclonic structure. Meteorologists around the world watched in disbelief as the storm's wind speeds increased exponentially. It was as if Hurricane Milton had appeared out of nowhere, defying all known models and expectations. Communities along the projected path were caught off guard. In Florida and Caribbean islands, the residents were accustomed to hurricane warnings, but nothing prepared them for the speed and intensity with which Milton was approaching. Evacuation orders were issued, but time was running out. As Milton barreled toward land, it intensified into a Category 5 hurricane, the highest classification on the Saffir-Simpson scale. But even that didn't seem adequate to describe its power. Wind speeds surpassed 220 miles per hour, making it one of the most potent storms ever recorded. Let's pause for a moment to consider the sheer magnitude of this force. Winds at this speed can demolish concrete structures, uproot massive trees, and turn ordinary objects into deadly projectiles. The storm surged a dome of seawater, pushed ashore by the hurricane, reached heights of over 25 feet, inundating coastal communities and causing catastrophic flooding. But what caused Milton to become such a monstrous storm in such a short period? Scientists were baffled. Traditional models couldn't explain the rapid intensification. Some speculated that unique atmospheric conditions created a kind of perfect storm scenario, while others began to consider the unsettling possibility that climate change was accelerating the frequency and severity of such events. Amidst the chaos, a team of daring scientists made a bold decision: to fly directly into the eye of Milton to gather critical data. Equipped with the most advanced technology and flying a specially reinforced aircraft known as a Hurricane Hunter, they embarked on a mission that could easily cost them their lives. Before we delve into their harrowing journey, if you're captivated by this story and want to explore more incredible narratives like this, make sure to subscribe to Cosmic Chronicles and turn on notifications. Give this video a thumbs up if you're finding it engaging. Now, let's continue. As the Hurricane Hunter approached Milton, the crew could see the towering walls of clouds, known as the eye wall, swirling with unimaginable fury. Turbulence rocked the plane violently as they penetrated the outer bands. Instruments beeped and buzzed, recording data at a feverish pace. Suddenly, they broke through into the eye, a momentary oasis of calm amidst the surrounding chaos. The sky above was clear, and the ocean below eerily smooth. But the respite was short-lived. The eye wall was closing in, and they needed to act fast. The scientists deployed dropsonde devices that measure atmospheric conditions to collect data on temperature, humidity, pressure, and wind speed. What they found was unprecedented. The temperature differential between the eye and the outer bands was far greater than anything previously recorded. Humidity levels were off the charts, and the barometric pressure was astonishingly low. Dr. Elena Martinez, the mission's lead meteorologist, later recounted her experiences. It was like entering the heart of a living, breathing entity. The energy was palpable. We knew we were witnessing something extraordinary, something that could redefine meteorology. But then, disaster struck. The aircraft's engines began to falter due to extreme icing conditions, something that wasn't supposed to happen at the altitudes they were flying. Navigation systems glitched, and communication with ground control was lost. For a tense few minutes, it seemed as though the crew might become victims of the very storm they were studying. Miraculously, they managed to stabilize the aircraft and exit the eye, but not before witnessing phenomena that defied scientific explanation. Electrical discharges, unlike typical lightning, danced around the plane. Some crew members reported a sensation of static electricity in the air, even inside the cabin. Back on the ground, Milton was unleashing its full wrath. Entire towns were leveled. Power grids failed, plunging millions into darkness. Emergency services were overwhelmed, and resources stretched thin. Yet, amid the devastation, stories of incredible human resilience and compassion emerged. Communities banded together to rescue those trapped in debris. Volunteers from neighboring regions risked their lives to bring supplies and aid. Social media became a lifeline for coordination of relief efforts, with people using whatever means they had to help others. As Milton moved inland, it began to weaken, but the path of destruction it left was unlike anything seen before. The immediate concern shifted to humanitarian aid and rebuilding, but questions loomed large over how such a storm could have developed so rapidly. The data collected by Dr. Martinez and her team became the focal point of an international scientific investigation. Researchers from around the globe collaborated to analyze the findings. Advanced computer models were developed, utilizing machine learning algorithms to process the vast amounts of data. One startling discovery was the presence of unusually warm sea surface temperatures in the area where Milton formed, up to 5 degrees Celsius above average. This excess heat provided the energy that fueled Milton's explosive growth. Furthermore, atmospheric conditions exhibited anomalies that suggested a possible link to shifting climate patterns. This led to intense debates within the scientific community and among policymakers. Was Milton a freak occurrence, or a harbinger of a new era of superstorms exacerbated by climate change? The implications were profound. If you're intrigued by the intersection of science, technology, and the challenges facing our planet, don't forget to subscribe to Cosmic Chronicles. We're committed to bringing you in-depth explorations of the issues that matter. Like this video if you're finding it informative, and feel free to share your thoughts in the comments. Your engagement helps us foster a community of curious minds. Returning to our story, the aftermath of Hurricane Milton spurred action on multiple fronts. Governments convened emergency climate summits. Investments in renewable energy surged as nations sought to reduce the greenhouse gas emissions linked to global warming. There was a renewed focus on sustainable practices and environmental stewardship. In the field of meteorology, Milton became a case study for improving predictive models. The limitations of existing forecasting methods were laid bare, prompting a technological revolution. Satellite technology was enhanced, and AI-driven models became standard tools for predicting storm development and paths. Communities affected by Milton embarked on the long road to recovery. Rebuilding efforts incorporated new architectural designs aimed at withstanding extreme weather. Infrastructure was fortified, and early warning systems were overhauled to provide more accurate and timely alerts. But perhaps the most significant change was in public consciousness. Milton served as a wake-up call, highlighting the tangible impacts of environmental neglect. Grassroots movements gained momentum, advocating for policy changes and personal responsibility in combating climate change. Let me share with you some personal accounts from those who lived through Milton. Maria Rodriguez, a teacher from a small coastal town, recounted the terror of the night the hurricane made landfall. The wind sounded like a freight train. We huddled in the basement, praying the roof wouldn't blow away. When morning came, it was like waking up on a different planet. Everything was gone. Her town, once a picturesque community, was reduced to rubble. Yet, Maria found hope in the solidarity that followed. People I'd never met before were suddenly like family. We shared food, shelter, stories. In the darkest times, humanity shines the brightest. Stories like Maria's underscore the duality of such disasters, the immense suffering and loss, but also the resilience and unity that emerge. As months turned into years, the lessons of Milton began to manifest in tangible ways. Education programs were developed to teach the next generation about climate science and sustainability. Businesses adopted greener practices, not just for public relations, but as a core part of their operations. Internationally, treaties were signed to limit emissions and invest in green technology. While progress was uneven and challenges remained, the trajectory was clear. Milton had catalyzed a global shift in priorities, but the question remained, would it be enough? Scientists warned that while steps were being taken, the window to prevent irreversible damage was closing. They emphasize the need for continued vigilance and action, both at the policy level and within our daily lives. As for Dr. Martinez and her team, their work continued to push the boundaries of meteorological science. They developed new instruments and methodologies for studying extreme weather. Their experiences in Milton's eye became legendary, inspiring a new generation of scientists dedicated to understanding and protecting our planet. Before we wrap up, I'd like to invite you once again to subscribe to Cosmic Chronicles if you haven't already. By joining our community, you'll stay informed about the most pressing issues and fascinating stories from around the world and beyond. Like this video if it resonated with you, and share it with others who might find it meaningful. In conclusion, Hurricane Milton was more than just a meteorological event. It was a turning point. It challenged us to confront the realities of our impact on the Earth and prompted a re-evaluation of how we live and interact with our environment. The storm revealed both our vulnerabilities and our capacities for innovation, compassion, and resilience. As we face the future, the legacy of Milton serves as a reminder that while we cannot control nature, we can control our actions. The choices we make today will shape the world for generations to come. Thank you for accompanying me on this deep dive into the extraordinary saga of Hurricane Milton. Your curiosity and engagement are what make these explorations possible. Remember, knowledge is the first step toward meaningful change. Until next time on Cosmic Chronicles, keep looking up, stay curious, and never stop exploring. See you soon!